And we are live. Welcome everyone to the first edition of TestMu. We are delighted to host everyone here today. This has been a special edition for all of us, and we hope it was as special for you too. I'm Anmol Gupta, and I'll be your host for this session. Before we start this session, we would like to thank all our partners for supporting and promoting us for this event. So, without further delay, let's get into it. I'm delighted to introduce you to Gil Zilberfeld. Gil has been into the software since childhood, writing basic programs on his rusty Sinclair ZX81. Gil has more than 2 decades of experience developing commercial software, from automated testing to exploratory testing, design practices to team collaboration, Scrum to Kanban, and lean startup methods. He's done it all and still learning. In this session, Gil will speak about concrete examples of anti patterns in tests and how to clean them up. So let's give a warm welcome to Gil. Over to you, Gil.
Thank you very much. Welcome, everyone. I'm glad to be here on TestMu. I think it's my first conference with a Greek letter in it. So, yeah. I hope you enjoy it as well and have a lot of other letters as well. So, today we're going to talk about not dogs, unfortunately, but dirty tests and clean code and clean tests and why we want them. And wow, so there's also already a question. Yeah, if you have questions, put them in the Q&A box. I'll try to answer them if they fit my flow. If not, I'll try to do that at the end. Hopefully, we'll have enough time for that. We'll probably have enough time for that. So whatever's on your mind, put it there, and let's get going. Um, so who am I? I'm Gil. I'm from Israel. I'm a consultant and a trainer for all kinds of things that people want to learn about creating better software. What you see on the left-hand screen are my books, Everyday Unit Testing, Everyday Spring Testing. I teach and train about these things, clean code, clean tests, automation, stuff like that. You can get in touch with me with the email, on Twitter. Um, get to testingil.com or everydayunittesting.com, which redirects there, and read blogs, videos like this. I'm going to show examples today in Java, but first you can find some recordings there with other languages as well. And the things I'm going to talk about today are like universal, even in Klingon they work. So people ask me, Gil, do you write clean tests? And the answer is, yeah, I really try. I really try. It's very hard to write clean code and clean tests as well. And I'll get into it why it's so hard. But even think about it. What makes code rot or tests rot? Well, they don't. Like code doesn't change. It's we that change. So like every 3 days after I've written any code, I will have this kind of expression. I'll try to find somebody to blame, but it's usually me. It's easier when you find somebody else to blame, like somebody else's code. Most of it is because it's not like we don't like it. It's like we wouldn't write it like that. But that's a completely different session. The thing is that, yeah, we don't like these kind of things. And there's a reason, I think, why tests suffer a bit more than regular production code. Um, Test code, production code, basically they're the same thing. We should apply the same standards, but we don't. Um, like we can apply the same standards if we don't have anything to do with clean code, so that doesn't matter. But we're here to talk about at least have some kind of motivation to write clean code and clean tests. So we want to do that, but we don't, and there are a couple of reasons why. First of all, we know that the real code, but well, it's not like real code, right? Real code goes into production. It's going to be used by real users. we don't consider ourselves real users, although we know we will be the users of this code. So that's one thing. Second thing is like there's kind of an evolution of code, which in test it's a bit different because we write a test and it passes, and then basically it goes back in our mind to somewhere else, and we probably think we'll never see that one again. We know we will, but we're kind of focusing now on the next one, and we kind of forgot about it, and this one already passes. Should I go back and refactor it and do something like that? Nah, let's focus on the next one, make it pass. So first of all, it's the focus thing. It's our perception of like differences between which code is which and why, how real it is. And next is with like whether we go back to test. And if you think about it, we go back to production code as developers a lot more than test code. Test code mostly passes, unless they're really like broken test, fragile test, regardless of how you want to talk about them and stuff like that. We usually don't go back until they break. So again, we do some kind of separation between the two kinds of code. Like action code, yeah, we will go in there. It will change. Tests, we're probably not going to go back to the one that we actually wrote just one. Now, what are the chances? So in the end, we kind of think about these things differently. And honestly, we need to, like, we're going to do the same things, we kind of apply different standards. Now, when I talk to developers, I'm developers since like age 10 on the ZX. They usually agreed with what I'm going to show you next. And like this is their job. And basically, this is what we want as developers. We want code that works over and over again. Now, the code that works, to some kind of definition of what works. The product managers, the teams, the customer, whatever, the organization, business. But we want to do this over and over and over again. It's kind of regardless of your method of development, call it agile or quote agile or even waterfall, it doesn't really matter. We kind of do this in iterations, even if the iterations like 3 months. And it's like we start over from scratch every iteration, right? So we go back into the code as we want automated tests to support it there. And the same is true also for the test code. So the part of keeping the code clean and our tests are basically around the second part, the over and over again part. So yeah, we kind of need to get out of this mindset of tests are not real code, because when people actually think about it, yeah, they kind of get shocked like The Rock did in the movie. So I'm going to talk a few minutes about what clean code means to me, but I want to start with what I think is at the bottom of clean code, which is about time. See, as developers, we like to work on new stuff. Going back to something that worked before but now doesn't work, like it's kind of backward step, like flying back in time. So keeping code clean basically allows us to create new stuff, the over and over again part. And by basically reducing the time we spend on the old stuff. Like if we could read the code, we would spend less time in it and then move back to the new cool stuff. So keeping code clean and test as well, I see that as like being respectful for the time of future me or future you. So basically, we would like to keep the code clean all the time. That's the motivation around this. Obviously, we can translate that into readability and maintainability, anything. But going back to the goal, working code over and over and over again, basically translates to how much time and effort we actually put in now, invest now, in order to free some time in the future. Time, effort, pain, lots of stuff. So you've probably seen this kind of thing before. How good code versus bad code looks like. Today it looks a bit different because most of the code reviews are done not at the same room, but through pull requests, which is kind of a sad thing. So basically the WTFCC here basically are being sent by mail or Bitbucket or whatever you're using. But yeah, there is some kind of truth to that, because basically when we review code, we see it in other eyes, not the ones, another person who wrote it, because the person who wrote it basically created the most magnificent code that he ever created. Otherwise, you wouldn't say that it's done, right? So I wrote the code. I can review my code, but I will say, yeah, it's great, ship it. We need other people to view it as well and tell us, well, is it good? Is it readable, maintainable, all the able stuff? So I collected a few quotes about clean code and what it means to other people, like smarter people than me. The first one is Grady Butch, one of the big brains behind the object orientation movement until today. He said, clean code is simple and direct. It should be written like prose. So this is like one thing I show everybody. Like, try to read your code. Does it read like prose? Does it read like a book? And usually either it's a bad book. But we'll see, like technically, something happens that kind of break the readability. So this is interesting because like it says like I need to read something like a book tells me a story. Tests tell story as well. So can I read the story out of my tests? Michael Feathers, who wrote, I think, for me, the Bible on unit testing, it's called Working Effectively with Legacy Code. He said, clean code always looks like it was written by someone who cares. So what does caring have to do with it? We care about people. I think caring about people's times. So it's kind of a respect. We're doing an investment in our code in order to make sure that other people are happier when they're working on something else. Quite a few questions, which I probably will do at the end. So I'm sorry. Yeah, two screens thing. I will continue and try to go over them at the end. Keep writing stuff. Yeah. Martin Fowler wrote as part of the members who wrote the Agile Manifesto. Any fool could write code that the computer can understand. Good programmers write code that humans can understand. I can attest to that. I think it was like less than 10 years ago, I was in a conference in the UK where I attended a workshop of test-driven development, TDD, in assembler, like jumps and registers and stuff like that. And when I finished, there was a program that was working, only like 5 minutes later, I couldn't read it. Like it's a foreign language to me, like assembler. Yeah, I could use a dictionary, and if I get into it, I will understand. The computer understands, it runs what it needs to do, but good programmers write code for humans to understand. It's not that it's even easier to write in higher languages than assembler. It's easier to write and to read. So, yeah. So everything I talked about is kind of thing I talk about in clean code trainings and stuff like that in my workshops, and same thing we want from our tests. Now, I'm going to talk about a couple of things that basically make clean tests. What? These are not just their things, but these are examples. And if you've written more than a few tests, you know that they're kind of built up in a certain way, and we want them to be used in a certain way. It's not that these things don't coalesce completely. So show intent. First of all, we were writing tests. Tests are like examples of how we expect to use the code, production code, in a certain scenario. So it's intent. How do you use it? What do you use it for? If you can't read it from there, from the tests, or you need like extra reading material, tests are not good enough. It's not that they're dirty or clean, but if we're looking for something from a book, we look for the story, and story has some kind of motivation behind it. We want to see that in the tests. Now, tests are also focused around something. It's easier to talk about unit tests in that in the concept, because unit tests kind of look at this code, run it, do some kind of assertion. Yeah, it's pretty much focused. But if we're also talking about other kinds of tests, like API tests or web automation or mobile or end-to-end, it really doesn't matter. They are doing more, but they're still doing something. If they're going to do multiple somethings, we kind of lose the story there. So unless there's a coherent story in there, we lose track. We lose track. That again goes back to misunderstanding and mistakes and more time in debugging. We don't want that. Not for ourselves, not for other people as well. But people know about a bit about clean code. There's something called the solid principles. The stands for SRP, which is the single responsibility principle. And much like in code, when you say like this piece of code is doing one thing and just one thing, we want tests to do that. It could be like different levels of thing of resolution, but when it starts doing multiple things, we will get lost. Even technically, like where did the story break, right? Where did the test break? It broke there. So we need to track like 5 steps or APIs earlier to see what happened there. Going to be translated into debug time and headaches and stuff like that. We don't want headaches. There's something I write here because I think it's important, because it is important, but we can't kind of put it aside because we wrote the test, of course. Of course, they do exactly what they say, but I can count a lot of times when I like started writing a test, give it a nice name, and then I wrote the test. And then I decided to go another way from where I was going, and I forgot to fix the test names. Now, thankfully, I found it somewhere down the line, like during a review or something like that, or I reviewed it, something like that. But if we don't do reviews, we can become at a point where the tests tell you something but do something else. What do you mean? What I mean, tell you something. When this kind of things breaks, what you'll see is the test name or description, right? This is what's going to be in a test report. When you open the test, because you forgot about it, it's not something that happened like the failure was 5 minutes ago, like you wrote it like 3 months ago. Now it breaks, and you try to like make the puzzle in your head about this is what it does, this is how it does it, this is the code that it takes. How does this thing fit together? And again, we'll probably figure these things out, but it will take time. So yeah, the test should like this should be at least some kind of coherence between the test name and description and what it does. If we can't read that, it's going to spend time on it. The final thing is something that happens a lot, and it's happening because of the tools that we use. And I'm not saying the tools are bad, but most of us use in test automation things that are basically general purpose, like JUnit. Yeah, it was written for everyone to use, and because Kent Beck, when he wrote it, he didn't have, apart from himself, somebody else in mind. So he wrote something that would probably fit a lot of audiences. So the API speaks a certain language, usually a low-level one. It's not going to speak the application domain one because it's general purpose. JUnit is fit for everything, right? From medical to finance to gardening and dogs. So what happens is, because we use a lot of frameworks and third-party libraries and stuff like that in our test, what happens is that you'll see that the test or the story speaks different languages. that's not a very good book. If you look like if you kind of need to switch languages in a book, it's hard. It's hard to keep the story in our mind, the focus, what we are trying to do, and it happens all the time. It not just happens in test; it happens in code as well. So we have a kind of solution for that. We call it abstraction. Usually because we use the third party and frameworks that are usually on a low level thing, usually lower than the application domains language. What happens is that they kind of intermingle, and we can abstract this into different classes, stuff like that. And when we do that, we give names, and these kind of names help us with the readability of the test. So abstraction is something that you'll see a lot in clean test. Even you'll see like when you extract an assert into something like it should do something, it's more readable, it reads better, it doesn't break the coherence of the test. I like the word coherence. So you've done a lot of coding. You know there are code smells. There are things that are basically are not problem functionally, but it will hurt the over and over again part of our story. So tests have those too. I picked a few, so I'm going and basically they are anti-patterns to how to write tests. These are the things I'm going to kind of speak about today and show you examples. The things are usually there are patterns that have a name and usually apply for clean code or unclean code, dirty code. God class are the classes that look like this. God methods are the methods that look like this. Now, with tests, it's a bit different. Like separation to classes and methods usually kind of makes sense in terms of architecture, stuff like that. Usually, we kind of have a mess of how we organize our tests. So you'll see a lot of God test classes, like giant storage classes, because they deal with one functionality, and whenever you add a new test, it just it fits here, let's put it here. And we need to kind of work around it, because otherwise like they kind of go into our storage classes, and this storage gets bigger and bigger and bigger. Comments, talk about that. Usually comments don't get updated. Comments in test we usually don't write a lot of comments in the test, but we do write test names and sometimes also descriptions, stuff like that appear in reports. And again, if they don't get updated, we have a problem there. Uncommunicative names, exactly what they say. Embedded constant literals, like things we'll see in the code itself, which can be renamed better. So yeah, I'm going to switch to I'm going to end this and show you this. So like I said, I'm going to show you the examples in Java, but the examples apply in every language. What I'm going to do is show you a bit like this code, which is what we're going to test, which really doesn't matter because we're going to talk about the tests themselves. So basically what you see here is a controller of a calculator, because well everybody loves calculators. So basically it's been run by an API, and if basically you send it a class called calculator params through its body, 3 parameters, first and second numbers, both integers, and the ops. The ops are basically the plus, minus, small. So I create this kind of object, send it as a body in the request, and basically it does plus for the plus, minus for the minus, and nothing else for the error. Doesn't really matter because we're talking about the test day. What does matter though are the consts, because I'm going to refer to them later. The consts are part of the production code. Basically, these are the routes for the different APIs. Going to get back to them. But other than that, doesn't matter. I'm going to start with a couple of dirty tests that I prepared. So I have a class called dirty tests. And I actually wrote it the way I write a lot of tests, which means I kind of, I'll start with the first test, basically creates a calculator params, fills it with the 3 plus 4, and then it creates the headers for the request and do the JSON transformation from the object to some kind of JSON, prepare the request, do the post for root/calculate, get the string back, and then asserts that it's 0. It's 7. It's not 0. 3 plus 4 is 7 today. Not sure about tomorrow. So what do I mean I write like this? I write like this because the next thing I'll do is, it's working, I'm going to do another test. Basically, copy everything. If I copy correctly, I'll also copy this. The comment also, by the, I wrote, check that we can add two numbers and return the right result of the string, which basically describes what it does. But yeah, you can see how helpful this comment is. Still true when you copy it. This time, because the very successful name TestEd was very good at the first, I needed to modify it a bit. TestEd minus. You see, I'm adding -5 and -4, but basically it's the same thing. This is something we do a lot. Once something is working, we copy it and modify a bit, because why write everything from the start? So I have this, and the final one, which I got tired of writing the comment, I wrote subtract number, called it test minus because I picked the names here, and do 20 minus 4. So basically, these are my tests. I want to make them better, and I'll do it step by step. The first thing I'm going to do is, everybody's used some kind of unit test framework or test framework. And now there's something that we can put in a setup function. In JUnit, it's called before each. But the patterns I'm using are taking, first of all the variables that are repeated. I'm going to extract them, and the pattern is called extract field, put them in the class, and initialize them in the setup. So basically, it looks like this. This is where, with the common setup, I extracted everything that's gets renewed with every test. In the before each, in the setup method, I initialized everything, and that's great. Look, I already squashed a lot of the things. Now, a setup method, usually, apart from initializing stuff, that's what we used it for, kind of is a common, it's a place for the common things that we want to do. So that means when we do that, when we move things to the setup method, what gets left in the tests themselves is what is different between the tests. That is good, because when one of them fails and one of them succeeds, we'd like to see what is the difference between them. Now, the longer the test and the bigger it is and a lot of rubbish it is, it will be hard to look at them and say, this is the difference between these. This goes into the if, this one goes into the else. But the more we squash these things, and we'll do that a bit more, what we'll get left is just the differences, which is very good for us. Okay, so obviously that was cool. Let's talk about the names. Obviously, the names are not that cool. Comments don't help, so let's do this with better names and no comment. So I renamed the first one add two numbers and calculate result. Add two negative numbers and calculate results. And the third one is subtract two numbers and calculate results. Now, this happens a lot as well. First of all, yeah, obviously it calculates the result. So why do we do that? And obviously this is what we wanted to do. Returns response, whatever. It's okay. If you see that kind of duplication happening a lot in the names, just remove it. I'm going to do that as well. So basically, I'm good with that. I'm going to now start removing more duplications apart from the names. So like I said, I'm going to, there's a lot of things still duplicated in the code, the creation of the request, going to extract that into a method. So we have the same setup method and the fields up there. Basically, what's left now is preparing the calculate parameters, and I extracted the method called calculate down at the bottom, which does everything the request. When I did that, I kind of thought about, well, I'm going to use this URL as a parameter, but At that point, I said, well, it all goes to the same point. Maybe we don't need that as a parameter. So we'll get rid of that as soon. So yeah, that's remove that application. Tests are beginning to look like what I'm going for. Like they actually focus on the things, don't have all kind of noise, and I can actually look at the different ones, different tests, and say, well, this one does that, this one does this. Cool. Thanks. Next, I'm going to tackle a couple of literals. So the first one is this one, the URL. So obviously, I can extract it called a local URL. Also, in this version, I realized like I don't need to pass it around, so I changed the signature. I don't call the call calculate method with the URL, just use the constant here. But I can do something more about this because, yeah, I can do that. But if you look at it, there are two parts to this. This is the first part, which is basically belongs to the test. These two things here belong to the production code. Remember, these are defined in the consts. So I can define a local URL at the setup. I'll create my URL from the const there. And what I create is nothing that is more readable, but is something that is less fragile. Because now if things are happening, get changed in the consts, the test will be modified. So kind of separated the worlds between the test world and production world. Good. What else? So next I'm going to do something about this kind of thing. Now, usually I'm going to show you a very simple example of that, but I want you to bear with me because what I'm doing right now is like adding a couple of numbers and setting an operation, right? Imagine that I'm using an API where I'm sending like the giant JSON thing or JSON that can be mapped into an object. Now, when I do that, and God knows I did it many times, I need to set up a lot of fields. Now, there's a pattern called a builder pattern from the great boring book of design patterns that talks about how to build objects. In our case, is data objects. And I will show you how to use it, and I'll show you what the benefit of that. So I'm going to create a calculator param builder object. It looks like this. Basically, it's the same pattern as a builder, so I have everything initialized, and this is a very big part of the plan. And I have like a flowing interface, like with first and second and with ops, so I can build something, and every builder has a build method which initializes the object, sets everything, and returns. So the tests look like basically this. Set up the same test now says param builder with first, with second build. So you see, I didn't say with ops. Why is that? Because I wanted to say the same thing I'm using with ops, which is the default. I set it to plus, means that when I only need to specify that field only when I'm using the subtract, for example, which is different than the default. Going back to my giant JSON thing, a builder can start from a default and let you specify just the changes. Again, this is very similar to the changes between the tests. The common stuff, we kind of hide it because it's common. It's noise. We can get to it. We can do stuff with it, and but just when we need it. If it's default, we can hide it. Tests become a lot less big, noisy, and stuff like that. And again, contain with them just what's relevant to our story. So that's the builder. I want to do something extra about this. Builder's cool. See what I have here are actual stories. What I do have here is like what I mentioned before, two languages. Well, this is the domain language, calculator params, call calculate, stuff like that. Here, this is not the domain language. This is the platform language. Object mapper, JSON, requests, HTTP, NTP, stuff like that, REST template. Now, first thing, we probably don't want this interleaved in our tests, like in the beginning. No, we don't want that. So it's cool, we could extract it here. But this can be also a general solution, not for this class as well. Why do we need to duplicate that as well? So we can move this method to a separate class. So I created a class called API call wrapper and moved everything HTTP here. And we're going to finish a bit. And this had a post with body. I left a URL here, and the tests kind of look like this. Only this method now just delegates everything HTTP wise to that class. Final thing I want to show you is something called differentiation. And with my example, I am using a lot of literals like 3, 4, 7, -5, -4. And you can say like these are like, well, regular numbers. Nothing is more important than the other. But sometimes you're going to use IDs. And IDs, some of them are important. Like your user ID, you put user ID equals 17. What is important? Is 17 like 18? Is 17 like 100? Is this a special user, or is number 18 a special user? So we want to do something like that. So we can, in this test, what I did in the last test, as an example, with first I created a constant called any number. I do that a lot with any user ID and stuff like that. And here I put something special, this subtractor. This is still 20, this is still 4, but my test reads a bit it highlights what is important and what could be anything else. So when I do some kind of refactoring or mushing around the tests, this will be a lot more clear to return to. So that was my examples. I'm going to finish quickly now so I can go to questions. So yeah, we talked about testmls and how to refactor them. We kind of squanched the garden class methods, removed the comments, put very communicative names, and meshed around with the literals and constants, using them with like real names, but also specifying what is important and what is not important. You do all that, you have very great test. You can smell the fine air of the tests, which we actually want. It's not what we really want. What we really want is this. Is when we look at the test code and production code, we don't see any dissimilarity or difference in the standards. We apply the same things, the same patterns we can do in the code, and we'll have great tests and great code and great tests and clean tests. And that's what I wanted to share with you today. So I'm keeping this on the screen so you can enjoy everything about my emails. I do want to go to the questions. So let's see. What's the best criteria to organize test cases? Oh, it's not only depends, it changes in time. So people start with like unit testing, with classes. Yeah, but then there's functionalities, and then there are workflows. So, but then some workflows are kind of, well, is this part of workflow this part of this? There is no criteria except the one you decide at this point of time. The thing is that you don't do it on a one shot. You can't, because if you do it on a one shot, that criteria will live for 5 years, and you will keep sticking tests when they don't really belong, but only half belong. So I'm sorry about this. This is something that should be done like every few weeks or months, depending on the rate of development, because there's a lot of time that's going to be saved by doing the investment in organizing your tests. Some of them will not be very relevant. Some of them you can delete some of them, hopefully. And this will change the organization. So yeah, it's work. What does mean by dirty tests? Well, basically, these are the things that people ask you to change during a review if they know what they're talking about. If you can't read it, after a week, it's not like you can't read it, but you spend a lot of time trying to understand what is going on in the test. This is a dirty test. Hi, Gil. Hi. How often do your team review and organize test cases? Do you follow any thumb rule? It's a very good question. So usually, the thinking should be done. Basically, not should be done. I use them in two sequences. One basically in the sprints. So when we're doing like test planning for the sprints, kind of think about, well, is this a new thing? Does this belong on things that we have? Maybe we should do some kind of thing of reorganization. The other kind of sequence is like releases or whatever you want to call it, when things are going to change much. So kind of do that. It's mostly like it's like design that you're thinking about all the time. So you think about that all the time as well. How often
Gil,
should we? Yeah,
sorry, so there are a lot of questions which are
yeah, they are.
almost similar. So let me just share a few questions which I have sorted.
Yeah, go
So,
ahead.
yep,
Oh, that's
we
good.
have a question from Avinash who says, "How do I prevent unknowingly duplicating the code?"
um, well, the unknowingly is kind of suspicious here. Usually, you're the one who actually duplicate the code. But code application, basically, you basically find it in two ways. One is through regular reviews. People who have seen this code somewhere else, they will tell you. There are tools to look for some kind of code application. And I'm talking about patterns, not just exact code applications, like Simian, and they look for similar patterns in the code. They can find it for you as well. Um, so this
Okay.
would be like a good point to start.
Okay. We have another question from Arun who says, "What are the other patterns that can be utilized similar to your example of builder patterns in test automation?"
Anything. Design patterns basically, like we use a singleton, right? We use, sometimes we call it the evil singleton. There's nothing evil about it. It's the usage. It fits some kind of uh, uh, operations. Can fit as well into a test. For example, if you're going to initialize a database as part of your tests, and you're going to do it once for the rest of the
Mhm.
test in your suite, it's kind of a singleton. So you can look up and see where patterns exist and relate to actual code. Tests are going to be the same way. Same standards, really.
Okay. Next up, we have another question. I believe everybody has their own, I guess they want to say, style of writing code. So, how do we engage in the practice of writing it clean?
So yeah, it's a very good question because it's not a clean testing. It's a clean code thing. It's not even a clean code thing. It's a team standard thing. So basically, everyone has their own styles. And if you're doing a code review for someone, you should basically think in your mind. Basically, when you're doing a review and you want to say, well, this thing looks wrong. Does it look wrong just for me because I would have written it differently? Or this is the way we want everyone to write code this way. So when you're doing this kind of thinking and you don't like do like whatever, get a laundry list of all the comments that you want to say because you would have written it differently, but say that these are the kinds of things that are important to fix and teach everyone about. These are the things that kind of build the standard for coding in your team. And I think this should be like the end result of a code review and test review should not be like the best code ever, because it would be like subjectively for my best code. But we're kind of building the things that are important for the team. What I call, this is how we write code here. So when we do that and we kind of concentrate and focus on these things,
Mhm.
basically people get their styles because it's not really important. If I can read your style, that's okay. That's if I don't understand your style, that's something else. But if I read it a couple of times, then I understand it. You keep reading, writing like that. I'm going to continue reading like that. Nothing happens. It's not like going to be a big time loss. What is important when we decide that it is important for everyone, we should spread around it this way. Like these are the things that we comment about in code and test reviews. And usually this should be a smaller bunch than what we really think about.
Right. We have one more from Ruth, and I guess this is something which we all have done at some place. Is it sometimes easier to just delete the tests and then rewrite them from scratch rather than try to improve what's already there? What are your views
First
on
of
that?
all, yeah, and that's true for code as well. Um, there's a deeper meaning in that. First of all, it probably was going to be easier because the tests were written not yesterday, but a year ago. So trying to get into the mind of the code of somebody else's, what they were thinking, what they were assuming at the time, that's going to happen. And what happens around this code since then is going to be like very big endeavor to do it correctly and right on the first time. So obviously, deleting and writing from scratch usually um, is going to be easier, but and simpler. But it also gives you an opportunity to ask: do we really need this test? Do we need it to rewrite this? Maybe it was tests are about risk, right? And this was the test what was written was very important to know that things will happen this way a year ago. Is it still true? Is the risk still high? So maybe you don't need this. Maybe you can replace it with, I don't know, a lower level test. So you had an web test that lasted for 5 minutes and would break like right and left. But then you know that at this point it kind of looks at this kind of logic here. Maybe a unit test that will run every time is better for that. So yeah, if you're getting into a point where you're actually evaluating tests, are they still relevant? Should we throw them away? Should we rewrite them? And maybe write them at a different level. It's a good point to have. So yeah, delete and also delete code. It's good for you.
Awesome. I guess we can just squeeze in one last question. So Manish asks over here that what are some good practices that we should follow during code review?
There are a lot of things. I did two things. Be nice. Because you're reviewing. You know, the people say like, "You are not your code." Cool, true, but the people who are doing the reviews, they are not the owner of the code as well, or the guardian of the code. So it's code. It can be replaced. It could be written in different ways. So one, be nice. Second thing, think about whether it is something that is important, so everybody will learn how to do this, not because this is how you would write it. Because when you do this kind of distinction, I would write it differently, then kind of people start thinking about, well, okay, if I can still read it, that's not a big problem. So as long as you keep these things, you kind of you will separate the important stuff and the not so important stuff that everybody can read and can read everything, read and understand very quickly. So it's a lot of when we're doing reviews, we kind of think about in our glasses, look at it in our glasses because we would have written it differently. Yes, we would have. That's not basically. If you actually think about it, we might have written it differently and more badly. So don't think about doing this. Think about kind of living out to what's important to teams in terms of standards.
Right. Awesome. Thank you so much, Jill, for this wonderful session. I hope all the attendees also found this session very insightful. I personally found it very insightful.
Thank
And
you. And
yeah, please continue. Please continue.
we don't have time for now, if you want to ask questions, so go back to my get me on Twitter or where is it? Twitter or email, and we can continue the uh, discussion there.
Yep.
Otherwise, it's been great.
Awesome. And for all of you who are watching us, if you want to catch any of the TestMu sessions later, we would be hosting all our recorded sessions on YouTube. So you can go back and listen to them again and share them with your peers. Thank you so much for joining us today. Have a great day, evening ahead of you. Bye.
Thank you. Bye.